Now, creating the key pair actually for SSHing into the server is not very optimal if we have to do it manually all the time, right? If we have to go to the AWS console and then we have to create it here and then download it locally and copy it to the SSH folder and set its stricter access and so on. So it's all a lot of manual work still, right? So how can we actually automate this using Terraform so that we don't have to do any of this manually? So let's go back to the config file, and I'm actually going to create a resource called AWS key pair. So we're going to create the key pair using Terraform instead of doing it manually. And let's call it SSH key. And we have two attributes here. We have the key name, which is the name given here. Let's call it server key to make it different from this one. And the second attribute is public key. So basically it means that we need a public key so that AWS can create the private public key pair out of that public key value that we provide. Now the question is, where do we get the public key? Now locally on your machine, you can actually create your own private public key pair, right? And that local key pair is actually located inside the SSH folder, right? So inside SSH, we have something called ID RSA, and then we also have ID RSA pub. So this is the public key, and this is the private key, right? So if you don't have this key pair, or if you don't have the SSH folder at all, you can very easily generate it, including the SSH folder, by using a command called SSH keygen. So if I execute this, it will basically create a key pair locally, and you will end up with the same SSH folder or .ssh folder and these two keys inside. And ID RSA.pub is actually the public key that we need as a value right here. So once you generate that key, or if you already have that available locally, what you can do is you can basically just grab that value by just outputting it in the console like this, and then just grab the whole output, including the email at the end, and paste it in here as a string. So it starts with SSH RSA and it ends with your email. So basically the whole string will be a value in here. And that is going to be your public key. Now, again, this is something that you probably don't want to check into the repository, or something that each user of this configuration file will basically want to override locally or set themselves, because every user will have their own public key. So either we can extract it into a variable, and every user of this Terraform project can configure it locally in their own variable file copy. So we can be public key or my public key. So we can reference it here and then define the value right here. That will be one option. Or we can also reference the file location, right? So we don't have to actually provide the string here. We can just set it to the file location, which makes sense because maybe you don't want to have the whole content as a string here. So what we can do here is $, and then we have file. And this basically will read from a file. And this is going to be a location of the file. And again, maybe this location is different for every user of the project. So we can actually make this configurable. Let's do public key location. So this is how you can use file or read from a file to set a value in Terraform. So we have to define this variable, and we're going to have to set its value right here. And this could be an absolute path. So in our case, or in my case, I can set it to this. And this will be basically the file or the public key location on my laptop. And basically each team member or user of this project can configure this location and file name themselves. So we make it more generic and reusable for everybody else. Great, so now this will basically create the key pair, and we can reference this key pair in the AWS EC2 instance now, right? So we have the old key pair as a reference here. Now we can update it and set it to the new one. And instead of hard coding it, we can just reference the key name from the resource. So let's do SSH key and the attribute name. And now let's actually do Terraform plan. I'm going to exit from the server and let's do Terraform plan. And this is actually very helpful if you make changes to existing resource and you want to know, first of all, if your configuration is valid. So validate that first of all, and second of all, you want to know whether that resource needs to be recreated, right? So it means that whether the attributes can actually just be replaced or does the whole resource need to be recreated. And in our case, we see that the server must be replaced, so it has to be recreated. So the old one will be removed and a new instance will be created in its place. And the reason is because we're changing the key and it is not something that we can just exchange in a running instance. In this way, Terraform knows that it needs to recreate the resource. And we also see a warning here for our syntax, which basically says that the interpolation, which is a fancy word for just combining the string and variable into one string, basically, is deprecated for specific cases where you don't have a string inside that, you only have the variable. So we also have a suggestion. We can actually fix that warning by removing this whole bit here and leaving this expression, which actually is cleaner. So we can validate that as well. So this is also interpolation. However, here we have variable and a string. So we don't get a warning for that. However, here we only have a variable reference and we're calling this file read method. So no interpolation needed here. So let's actually run Terraform plan again. And great, so the warning is gone. There was a small syntax issue and this is the same output. So now we can actually do Terraform apply, auto approve. And let's actually refresh this. And as you see, our previous EC2 instance is shutting down and a new one will be created in its place. And it was destroyed and now a new server is getting created. Let's refresh it again. The old one is terminating, new one is getting initialized. So let's wait for that to finish and then we'll be able to SSH into it. And while we're waiting, we can actually add another output in here that will print us the public IP of the instance that we just created. So let's call it EC2 public IP. And we can get the value from AWS instance, my server, and now we need the attribute name of public IP. And like previously, we can also do Terraform state show And we can just print out the attributes of EC2 instance. And one of them is public IP, and this is what we need. So, and let's save it for the next apply. Let's refresh it again. It is initialized. So now we can SSH into the server. Now, in this case, we used our own public key and associated that with the EC2 instance. So we don't have a .pem file actually, right? So how do we SSH into this instance? Let's go to the terminal and do SSH EC2 user, and let's actually grab the public IP of that instance. Like this. So now we need a private key, just like the PEM file, that will allow us to SSH into the server. And the private key of the private public key pair that we used is actually this one, right? So we used ID RSA.pub as a public key, and its pair, because it's a public private key pair, right? So we have those two parts. So we're gonna use the private key to SSH into the server. And the private key happens to be this one right here. And this will basically allow us to SSH. And there you go. This is the new instance that we just created. However, let's actually exit and show you a shortcut for this. Now, because this is actually a default location for the private key, so whenever you do SSH, this will be actually set as a default. We can just leave this out and just do SSH. And there you go. We can still SSH into the server because these two are actually equivalent commands. So you don't have to even specify. So that's actually one advantage of using the local, your own public-private key pair. And again, we created a server and we were able to SSH into it. So that means we can actually clean up and remove the server key pair.pem that we downloaded because we don't need it anymore. We can just use our own key pair. So I'm just gonna remove it. Let's do yes. And let's actually check that it has been removed. And there you go. The tab completion cannot find the file, so it is not there. And we can actually remove the previous key pair as well. We don't need that anymore. And delete. Great. So we have automated the part of creating the server key, the SSH key for the EC2 instance, also with Terraform. And there is a really huge advantage in automating most of this stuff with Terraform and doing as little as possible manually, or in ideal case, doing nothing manually. And the clear advantage of that is, first of all, when you are creating a lot of resources and you end up creating some of it and configuring some of this stuff manually, there's a high chance that you forget about these things when it's time to clean up the resources, right? So when you delete everything using Terraform Destroy, you may actually forget to delete this stuff that you created manually or configured manually. Another case is if you want to replicate the environment, right? So you created a development environment and then now you want to use the same Terraform configuration to create a staging environment. Again, if you created some of the parts manually, you have to remember and do the same thing on the staging environment because they're not part of the config files. And this means that you have to document that somewhere and you have to know these steps and remember, or if someone else is doing, you have to tell them and share that knowledge with them, right? So there's a clear advantage of automating and basically writing all the code that possible inside the Terraform configuration file and not doing and configuring stuff manually. So that is actually a best practice, a preferred way of doing it, with a clear benefit of basically saving time and doing all these things like creating a key pair here and then downloading the file and then saving the file somewhere and so on, because doing stuff manually usually takes more than just configuring it once and then applying it as many times as you want.